marginal cost, marginal revenue, marginal profit. There's also marginal demand and marginal average cost, but we're going to look specifically at marginal cost and marginal revenue. Marginal in business is a term that means rate of change. So marginal is the same as rate of change. So when I say marginal cost, that will refer to the rate of change of cost. Now we're very particular about rates of change. It's the rate of change of cost per unit quantity produced. Because cost is part of your expenses when you make a product. So marginal cost is the rate of change of cost per unit quantity produced. Marginal revenue then would be the rate of change of revenue per unit quantity sold. Marginal profit is rate of change of profit per unit quantity produced and sold. So let's look at a revenue problem. Revenue in dollars for Q meals at a buffet where everything is a single price. And let's say that the marginal revenue is $5.03 when 10 meals are sold. So I can write that as MR of 10 equals 5.03. And that means the rate of change of revenue per unit quantity, which is one meal sold. So marginal revenue of 10 equal to 5.03 means if I sell one more meal beyond 10, the total revenue increases by $5.03. I can say revenue is increasing $5.03 when 10 meals are sold. I can say that marginal revenue is $5.03 and is the additional revenue generated from selling one more meal after 10. In other words, that would be the revenue generated from the 11th meal. There are a lot of different phrases that go along with this, and they're in the examples in the lessons. So there are many different meanings that basically mean one more item beyond what our total is at this point. So our revenue increased $5.03. Let's look at a little bit different version of this revenue problem. Marginal revenue at 100 is negative 1.26. Marginal revenue is a negative 1.26. Well, from our wording, at 100 meals sold, the revenue for the 101st meal is $1.26 less than for the 100 meals. So if I have a total revenue for my 100 meals, when I go to the 101st meal, my total revenue is a little bit less than that. Now think about it for a minute. If we have a quadratic revenue function, one of those whose graph is a parabola that opens down, remember that there is a maximum revenue. That's the vertex of the parabola. So the revenue function, as it's graphed, revenue increases. Revenue is income, so it increases. Say I get up here and my revenue is $150 on this side. I get up to the top, revenue is $200. That is the maximum revenue I can get. And if I continue to sell more meals, over here my revenue might also be $150. It's a strange concept, but that's certainly possible. So it is possible, say on this downward side of my parabola, for marginal revenue to be a negative number because it is a rate of change. And over here, my rates of change are negative because my revenue decreases, but my quantity, Q, is still increasing. So I can have a decrease in revenue with an increase in the number of quantity sold. We'll look at some more examples of this. Now, when you think linear function, think equation of a line. So we're working with y equals mx plus b. Now, our standard cost function, cost, is equal to variable cost plus fixed cost. Our variable cost is actually variable cost per unit multiplied by Q, which is the number of units. So all of that is what variable cost is. So cost is actually variable cost per unit times Q, number of units, plus fixed cost. Well, if we have a linear function, the variable cost per unit is a constant because it's a straight line. Straight lines have constant slope. So for linear, the variable cost per unit is slope, which is a constant. So my cost function, C of Q, can be written as M times Q plus whatever the fixed costs are is B. Our fixed costs are B if it's a linear function. Now the slope M, in terms of cost and quantity, M is slope. We know it's a constant. It is change in cost, because that is the function name, divided by change in quantity, because our variable is Q. So this is change in C over change in Q. Now if you think about marginal was the rate of change in cost per unit quantity. So that the slope that is our rate of change is also marginal cost. So for a linear function, the marginal cost is the slope. If I have a cost function C of Q equal to 6.5Q plus 300. Marginal cost is equal to 6.5. It's a constant. And it is the same as the slope. Now, if this were nonlinear, if we had a quadratic cost function or exponential or something else, the marginal cost would not be a constant. But we can't do those yet until we get further along in our calculus. So if the slope of a linear cost function is marginal cost, let's think about what this might say for a revenue function. Suppose revenue is a linear function. Well, revenue is price times quantity. And let's think about revenue as so that price is just a number, not a demand function. So that revenue is P times Q. And we'll make this revenue of Q so that the price is a numerical amount. And if you think about this as a linear function, I have price is M. That's the slope. The Q is like the X. And we have a plus B for a linear function. And in this case, for revenue, the plus B is just plus 0. So for revenue function, marginal revenue is rate of change of revenue with respect to cost, so that the slope M is change in revenue over the change in the quantity. Change in revenue per unit quantity is marginal cost. So the slope is marginal revenue. And by the position that the marginal revenue, the slope is in, that's the price. So our selling price of a revenue function is marginal revenue, and it is the slope. And the same with marginal revenue. If it's nonlinear, we'll have to deal with that when it gets to be more complicated calculus. Specifically, let's look at marginal revenue, which is the approximate change in revenue earned from selling one additional item. So let's suppose our revenue function, R of Q, is the number of dollars in revenue earned from selling Q watches. So we're talking about watches. So let's suppose that R of 50 is equal to $1,500. So we sell 50 watches, we get a revenue of $1,500. Marginal revenue. Marginal revenue at 50 would be the approximate change in revenue if I sell one more watch. So by calling it 50, that really is going to tell me how much additional revenue comes from the 51st watch. Let's say that's $6. Now I can actually use this information to estimate other values of revenue if I'm selling more than one more. So let's estimate revenue received or earned from selling, let's say, 55 watches. If I just sell one more, I earn another $6. So my revenue for 51 would be $1,500 plus 6. But I'm now interested in selling 5 more than 50. So to find the revenue at 55, I'm going to approximate, estimate. These are not exact. The revenue for 55, I'm going to start with the revenue from 50. And I'm going to add on marginal revenue, but not just one. Marginal revenue is one item. I need 5 more marginal revenues at 50. So this will be approximately equal to marginal revenue at 50 is 1,500 plus 5 times my marginal revenue at 50 is 6. So I've got 1,500 plus 30. So I estimate that my revenue from selling 55 watches will be $1,530. Let's take another look at the company that produces mechanical pencils. The profit is equal to revenue minus cost. We found that our profit function was 2Q as pencils sold for $2 each times whatever the quantity is, minus the cost function, $4,700 fixed cost, minus 0.9Q for the variable cost. Make that plus 0.9Q for the variable cost. Fixed cost plus variable cost. So that our final profit equation was 1.1Q minus 4,700. Now we saw that when 3,000 units were produced, the company had a loss because 3,000 units produced and then sold was not enough to cover the cost. So they need to sell more or possibly charge more as a selling price, because you don't want to have a loss in your company. You want to make a profit, positive profit, or at least break even. And if you break even, that means that you don't make any money, you don't have a profit, but at least your revenue takes account of your costs. So let's see, if profit is 0, then 1.1Q minus 4,700 is equal to 0, and we'll solve and find out what quantity will let the company at least break even. Add 4,700. So Q is about 4272.72, about 4,272 pencils. Now remember, these are pencils, so we need an integer. If these were cases of pencils, we could have decimals. We could have a half a case or 7/10 of a case, perhaps. So this is the value that we've got if we want to break even. Now there is another way to look at breaking even. We talked about how the revenue has to be big enough to take care of the costs. So when profit is 0, remember profit is revenue minus cost. If profit is 0, then we can have cost equal to revenue, because then they would subtract out. So I can set revenue equal to cost. Revenue is 2Q. Cost is 4,700 plus 0.9Q. And if I subtract 0.9Q, I'll have 1.1Q equals 4,700, which gets us to the same place we have here. So there are two ways to think of breaking even. Either if you have a profit equation, set it equal to 0, or even before you get to profit, you could just set revenue equal to cost and solve it that way. Well, let's get back to this value for Q. We can't have 4,272.7 pencils. So what you want to do is to look at your rounding. You have to be very careful when you round in these problems. We could find the profit if we just chop it off 4,272 pencils. So it would be 1.1 times 4,272 minus 4,700. And the problem with this is, if I multiply this out, I get 4699.2 minus 4,700. This is going to be negative. That's not big enough. This is still going to give us a little bit of a loss. Not much, but a little bit. So let's see what happens if we use the higher value, 4,273. So if I put 73 in here, when I multiply this out, it's not really a whole lot of difference, but it is bigger than 4,700. So Either value probably would be acceptable, probably depending on shipping, if you have an odd number here versus an even number. So many other things to consider. But for it to be a profit that is positive, it would have to be 4,273 pencils produced and sold. Now this is the quantity. The break-even point also has a price to go with it, but usually what we're most interested in is our break-even quantity. And that would be this number right here. It's called the break-even quantity.